So let's finally talk about visual security event analysis. Whoa. Okay, I need to take this out here. So what I'm going to talk about is how you analyze log files or events that you have in a visual manner. I don't want to talk about myself too much. Maybe one thing, I've been involved in like log analysis and event analysis for quite a while, and it has always interested me whether there's a way to look at the data in a way that it really, like a lot of data, in a way that it's really apparent what is going on in that data set. And if you're looking at log files, thousands of lines of logs, it's really hard to figure out at one glance what is going on. You have to start reading through them, you have to like use your own mind to do pattern analysis and figure out what is really going on. So at some point, I started working for this company that I'm working for right now called ArcSight, and I got a hand on a lot of neat tools to look at data. And we got a feature in the software that is called Event Graphs, and I really liked it, and I started looking into how can we use this feature to make it more easy for a security analyst or a person interested in the log file to figure out what is really going on in that data set. So that's how kind of my passion about event graphs started. My talk here is not going to be very textual or like theoretical, and I'm not going to talk too much about how you generate the graphs and whatever. I want to show you a lot of examples on how to look at data sets and how you configure graphs to get the most out of it. As part of the talk, I'm going to show you a tool that I have up on SourceForge, which is called Afterglow, which is a very simple script, Perl script that transforms CSV files into a graph or language file, so you can go home and play with these things yourself, and the tool is actually also on the CD. I'm going a little faster in the beginning so we can catch up for the time I lost already. One thing, IP addresses and host names you're going to see in all these graphs, and the descriptions are obfuscated or changed. The addresses are completely random, and any resemblance with well-known addresses or host names are purely coincidental. All right, so let's do a little bit of an introduction here. Why would you want to look at these graphs? I guess this is a pretty good example already. Do you want to look at the left-hand side, or do you want to look at the right-hand side? Well, even if I made the font bigger on the left-hand side, it's probably still not very fun. All right, why do you want to use event graphs? I guess I already motivated that quite well. I'd rather look at the graphs. They look just much nicer. If you actually dig into it a little more and you start looking how to configure these things, you will see pretty quickly that you can visualize different properties in those graphs, and it's very easy to see certain aspects of a log file very quickly and certain things that are important to you. You don't have to wade through 10,000 of lines of logs to figure out whether there is anyone sending a lot of emails to someone else. If you use this in a security operating center or in a 724 response team or something, if you have graphs, they're a great way of giving you kind of like situational awareness or real-time view on things that are happening, and you can quickly react on them. And we have a lot of customers that are starting to use this in their SOCs, and it doesn't just look pretty on their big screens, but it's actually really useful. It's actually also kind of an interesting story. I was at one customer, and they had all these big displays, and they were empty, and I was like, wow, why do you have these nice graphs here on the analyst screens? Why don't you have them up there on the big screens? They were like, whoa, no, we tried that for a while. But then the boss came in, and he saw all these things on the screen. He's like, oh, what is this? What's that? What's this? What's that? So we had to explain all this. We took him off. All right, and another story that I had with these graphs, which actually two other stories. One is one customer uses these graphs to communicate with other teams. So you have the security analysts, they look at the log files and all that, and then they go back to the operators or the operational folks, and they're like, guys, you have to do something about this machine. It's talking to all the others in the network. And in the past, they were handing them log files to prove that it's that way. And the operators were like, whatever, we don't understand what this is. But now they started giving them graphs, and the operators were like, oh my God, my machine is talking to all these. Okay, we're going to take care of this. And even worse, I had one customer that actually just told me this week that he used the graphs to analyze some data, and he found some stuff, and one of the guys got fired just because he used the graphs and found out that one of the guys was not doing his work. All right, so I came up with like two big categories of when you use these event graphs. One is in a real-time monitoring scenario where you have like a screen up that looks real-time at certain properties of your data file, and I'm going to show you some examples on what I mean by that. It gives you great awareness of things that are happening. You can configure these things to, for example, look at transactions going to your financial servers. So right away, if someone connects to your financial servers, you will know. And then you can take it a level further. You can say, well, I know that these machines are okay to connect to my financial servers, so don't show me those, but show me everything else. So as soon as something pops up there, you know you got to look into it. The other thing is, if you take this in a more forensic or historical way, you grab a data set, you run it through some tools, and you look at the graphs on certain properties, and you figure out what's going on. Let me mention quickly some related work. There's some classics from Girardin-Luc. He did all these kind of things. He tried to figure out whether there are certain ways to visualize properties of data, and he took a lot of dimensions and put them all in one graph. What I'm going to do is I take a lot of dimensions too, and I'm always going to stay with event graphs, so like node-to-node connections. I'm not going to use any of the parallel coordinates or the right-hand, the bottom thing that I have no idea what it shows there. Then Erbacher, he actually went even further. He tried to go even more multidimensional and map everything into these nodes. So there's like size, there's shape, there's length of these spirals going out, and so on. Then Greg Conti, you probably have seen his talk, I hope. He mainly focuses on different ways to visualize TCP dump or packet logs. Very interesting. Then Envision IP is something I found. What you see up there is a grid of, I think it's 8 by 8 or 64 by 64. And they just map IP addresses in there. So you see certain clusters of things going on. The nice thing about this project is there's a lot of interactivity. So you can start playing with the data, you can zoom in, and so on. And then finally, a few of you might know Shoki from Steve Barry. It's basically a scatter plot. You can define like 3 different scatter plots, and then you have a 3D of that. So on the top right, it's not a very nice picture, but on top right, it's the 3-dimensional output. So you can say you want one axis is your source IP, one axis is destination IP, and the other one is like the destination port. All right, let's move on. How do you generate an event graph? Pretty easy. You have a log file that a device is generating. You take a parser. Why do you take a parser? Well, you need to know where in my log event or in my log file, where's the source IP, where's the destination IP, where's the event name, where's the port. So you parse that, you get the syntax right, and then you visualize that in an event analyzer. If you have an event, let's look at the Snort event here. You don't have to be really able to read this, but what I want to show here is in an event graph you can have different configurations. The normal event graph that you will always see is like who is talking to whom, so you have source IP, destination IP. But you can take this like a lot further. You can say, well, on the right top, you want to have the source IP, destination IP, and destination port. So you will see someone port scanning, for example, if there's a fan with destination ports. So you can configure these things in pretty wild ways, and I'm going to show you some of them. Now, let's have a sneak preview of Afterglow. I apologize because I don't use my laptop running. I can't show you the demo. It's not very fun anyways. I will show you the output anyway, so it doesn't really matter. So what is Afterglow? Afterglow is not a security information management tool. It's just a script which takes CSV files. So you have to somehow, from your logs, generate a CSV file, comma-separated values. And then you take Afterglow, the tool that I'm going to show you, and you transform these CSV files into a graph language file. And then you take a grapher tool, and right now I'm supporting 2 of them, that takes this graph language and generates the graph. And that's not something I did. I just transformed the CSVs into graph files, but I'm going to show you some cool things that we implemented there. So how you can use this thing is you basically cat the input file, you pipe it to Afterglow, you give it a color properties file, which I'm going to introduce a little later, and then you can use the AT&T GraphViz library, .neato, I'll give you references in a second, and you generate a GIF file. The color properties file is basically just, you tell it the source nodes are red, for example, the event nodes are green, and the target nodes are blue. And I'm going to show you how to really play with this stuff. We extended this quite a bit so you can have colors depending on the values in the log files. Big shout out to Christian. Thanks a lot for building the foundation of this tool. He built me the whole Afterglow Perl file, the basics and everything, and I just went in and made some small changes, but thanks a lot, Chris. Let's look at examples. I mentioned in the beginning, I kind of have two use cases, or two big categories of things to look at. One is what I call situational awareness, or real-time monitoring. So this is one of the views that I saw at a customer. Basically, you see here is 6 independent screens of different properties of your data that you want to look at. So here the configuration is such that on the top left, the customer wanted to see just the compromise attempts. And don't ask me how to filter for just those events. That's a whole different story. But if you have a way to say, these are my malware events, these are my DOS events, these are my scan events, if you can separate them by something, then you can draw all these screens and you can look at these screens and see what's going on. So what this customer is actually also doing, whenever an analyst starts his shift, he resets all the graphs so they're empty. So over time, nodes start popping up and they look at them and they're like, okay, this is fine. And they might filter them out even, or they just leave them there and say, okay, I know about this. And the more things that show up, the more they go along in their workflow and work with these events. So I have a feeling this is going to be a great tool, especially in a SOC or an analysis environment, to kick off your workflow. You look at these things and you take it on and you start building filters to filter out the things you know about, and you just see the outliers here in these screens. The second big group of use cases is forensic analysis or historical analysis, where you take a log file that you have and you visualize it. Afterglow can generate two kinds of outputs. One is for the AT&T GraphViz library for .NETO, and the other one is for LGL, the LAF graph, the large graph library. I will give a pointer to that in the end as well. This thing is generating three-dimensional graphs. You can actually generate VRML output, and you can fly through these things. I didn't prepare a demo because it's kind of fun to fly through it, but the analysis value is not really high, or the value you get out of it. It's really cool to fly through it and see that, oh, this guy sent an email to whom? Oh, there. Okay. It looks great, and I apologize for the colors here, but this is really how it looked. Anyway, let's go back to 2D. This is a very simple example, one of about 12 that I'm going to show, of how to analyze a log file. So what I had here is, I believe, like a snort log or a web log or something. And I said, well, show me what is happening, so the event name, the destination IP are the blue ones, and then the destination ports are the white nodes. So what you see here, all the blue circles are my web servers. The white boxes are the target ports that they're being connected to. So you see it's 80 and 443, so that's totally legitimate. Only HTTP and HTTPS traffic is going to my servers. So I probably don't have to worry about that. If I would see a node there, if like port 21, and someone connects to my web servers with FTP, maybe that's okay. But if I'm not running FTP in my environment and that shows up here, I probably want to investigate that. So it's a very quick way to see whether traffic is really what it's supposed to be. Or almost same configuration. Here you see source IP, destination IP, destination port. So this would potentially show you port scans or network scans. Here you see a lot of machines connecting to a lot of other ones, all on the same port. Down here, this white node here, is the port. So they all connect to the same port. Well, it could be that a worm is probing you, but it could also be that you have a web server and a lot of web servers and a lot of machines are connecting to those. So it might be okay, but it might be a scan. And depending on what the destination port is, you might figure out what's going on in this case. But you can certainly tell, well, this is all similar behavior here on this fan. And then, actually, if you see on the bottom left here, there are some little ones. It's probably worth investigating what those are, and probably those are the outliers that you're interested in. Let's keep this configuration of the graph. This is just a little bit of different data set in a different time. Looks much prettier. Let's zoom in on the bottom part here. What this is showing you that there are two machines, the red nodes, that are connecting to about 15 other ones and still on the same port. So again, in your environment, do you really have all these other 15 or 20 machines serving this one service and exactly two machines are connecting to them? So you can go and figure out what all these machines are, and hopefully they are really the ones that are serving this service, and then you can figure out whether these other two are really allowed to connect to this. Let's have a look at this weird thing over here. What you see here is, probably you can't read this, but there's a node here that says 21 FTP. So one of the properties of this graph is that the white nodes show up exactly once per target port. So everything that happens on port 21 is going to show up around that thing there. So again, I can say, wow, I have about 6 FTP servers, and about 5 people are connecting to them. So the FTP servers would be the blue nodes, and then the red ones that connect to them would be the people using it. So, well, is this really something I have in my environment? Is this allowed? And why are only 3 or 5 people connecting to them? Is that some kind of a process that, I don't know, maybe AIX that transfers log files over, something weird like that? Or is this something malicious? Is anyone having a where server or whatever? If you interpret these graphs, you have to be a little careful. I still have the same configuration. Destination IPs are the blue ones, and the white ones are the destination ports. Well, if you look at this on the left-hand side, I would say, wow, it's port scan. Well, is it really a port scan? I have a book for the one that gets this right. What is the left-hand side? No, not voice over IP. Who said that? Over there, you got the book. It's the source ports. The log file reports such that the source port is really the destination port and the other way around. So when you analyze these things, be careful and make sure you're really looking at what you're looking at. So why do I know this are the source ports and not destination ports? Well, they're in the 50,000 range. They're almost contiguous. And, I mean, who is scanning me on these high ports? We're not a capture the flag. There, they might scan you on those high ports because services are running all over. But here, there's really no sense why someone would scan you up there. There's probably nothing there listening anyway. So be careful when you analyze these things. Sometimes it's port scan, sometimes it's not. My first impression is always, well, false positive. Let's really figure out whether that's true. Okay, let's get fancy here. This is a firewall log. Basically, I show you passes and blocks from a PF firewall. If I would just visualize source IPs, destination IPs, I would see big clouds of things, and, well, I want to see a little more in this graph. So what I did is I have source port, rule number, that's the squares, and then destination IP. So you will see I'm connecting to some other machine, and rule number 100 is responsible for letting me in or blocking me. What I did then with Afterglow is to configure my node such that all the external IPs are going to show up as orange. I'm going to show you how to configure Afterglow to get exactly this graph. So the external machines are orange, my internal machines are green, and you see I only have a few of them. And then the rules are the blue boxes. And then further, what I said, I wanted to see whether a connection is incoming or outgoing of my network. So I configured the edges such that outgoing connections are blue, that's the majority here, and incoming is red. And I just realized it's probably exactly the other way around. I hope there is more incoming than outgoing because these are web servers that are servicing some stuff. Anyway, so you see big clouds of things that are showing similar behavior. So down here, there's this one rule that is responsible for letting in a whole lot of traffic. And probably that's fine. There's another one up here you can, if you know the rule set, if you know your ACLs, you can go and figure out whether it's really what it's supposed to do. But you can also figure out some things that are kind of weird. You have all this whole section in the middle. You probably want to zoom in on those and filter out all the others and just look at these things and figure out whether your rule set is really doing what it's supposed to do. So the next steps would be, so the first is like overview, general impression, what is going on, is there anything really sticking out? And then my next steps would be, I would visualize the firewall blocks of outgoing traffic. Why would internal machines connect outside and be blocked? So that's either a misconfiguration of the internal box or the firewall rule set is wrong. Then the second one would be, I would probably look at blocks of incoming traffic. I want to know who's probing me, who's poking around. And if you have a live system that can look at these things, you can put all these attacker machines maybe on a blacklist. And if you see them again and they're successful coming in, you might actually take some action and say, whoa, now someone probed me and now he's coming in. And then you can take this further. A third step would be to visualize the passes of outgoing traffic. Is this really what should be leaving the network? Maybe you find someone FTPing stuff out that you really don't want them to FTP out. Maybe you realize that you're running peer-to-peer clients in your internal network and they're connecting out, anything like that. And you can probably take a few more steps to analyze the data set, but I guess you get the idea. So this one is probably the wackiest graph I have. It's totally going away from source IPs and destination IPs. What I did here is I wanted to debug my firewall rule set. So it's still the same data set as before, but this time what I show you is the red nodes are the rule number or the ACL number, then the destination ports, and then you see the action taken, pass or block. So just by virtue of firewall rule configurations, you will see two distinct graphs. One on the left-hand side is all the passes, and the right-hand side is all the blocks. So here you can see, if you take one of these blue nodes, for example, port 53 here, you see that this one rule is responsible for letting traffic in. Well, is this okay? Maybe, probably, hopefully. But you have other ones where there are two nodes or three nodes connecting to the same rule. Like over here, for example, there are three ports being blocked by this one rule. Might be okay, might not. If you see something like this on the other side, that one rule passes traffic from multiple ports, maybe that's the way you configured it, but this is certainly a great way of analyzing and debugging your firewall rule set. This is another example where I took a TCP dump log, and what I visualized here is I take the region of where the source IP resides. So you can go on the web, there are databases that show you what the location codes are for the IP addresses. They're not very accurate, but in a lot of cases, they're actually pretty good. So I show you the source region, or where it's coming from in the world. Then I show you the source MAC address. So this is a TCP dump block. The source MAC address is going to be the last hop, probably my router, that led the traffic into my network. And then I show the destination IP. So what I see here, I have 4 boxes, the 4 white ones, that are my internal machines. And interesting enough, I have 2 entry points into my network. I have 2 source MAC addresses showing up. And then I have these 2 fans in the middle part. What this is showing me is either I have a redundant router set up, or maybe I have a load balancer. And what is interesting here is that all these machines up here, they're connecting through this guy. All these guys here are coming through both of them, and all these down here come through the other one. So maybe this is a regional load balancer that everything on one side of the world takes this entry point, everything on the other side is using that entry point. So if that's really the case, a great way to analyze this log is this graph here, and you can actually figure out why these 2 in the middle are coming through in for both of them. And this is just a zoom where you see the one server, and here it's like, can't even read it below the node here, but it's Sandhill or whatever, in the United States. All right. Graphs like these are a lot of times indications for worms, but again, be careful. There's a nice fan here of source IPs using the same event going to a few destination IPs. Well, it could be, again, it could be a worm that is using this one event to try to get into your network, but it might, again, be your web servers serving just legitimate files. What you have to do in this case, you have to figure out what is this event name here that connects all these dots, and this might give you an indication of a worm or not. If you're visualizing a snort log file and this talks about worm, well, duh, it's probably a worm. But if you visualize, I don't know, a TCP dump log file, like an ICMP port unreachable might be an indicator for a worm trying to probe UDP ports, and you get ICMP port unreachables back. So you have to investigate a little bit to figure out whether that's really a worm. I was playing Capture the Flag actually this year and last year, and I was trying to figure out the challenge really for the analysis team on Capture the Flag is that all the traffic hitting your web server or your servers seems to be coming from, or is coming from the same IP address. And there is malicious traffic of the other teams hacking you, but there's also benign traffic from the scorebot trying to figure out whether your services are still up. So blocking all the traffic is not working. So you have to figure out a certain way of distinguishing these two types of traffic. And you can't do it by the source IP, which you would normally do in your corporate environment. So I started visualizing this log file of TCP dump, and I just wanted to have a general feeling for what's going on. So what you see here, the dark blue ovals are destination ports that are below 1024. Normally services that are offered to the outside world. Then destination ports higher than 1024 are light blue. And then you see here what I just explained, the red node, this is what all the traffic that's coming in is coming from this one IP. And then I configured it such that our machines, the internal targets are green, other teams' targets are brown, and then internal sources are yellow, and internal targets are the boxes. So what you see here, we have two servers. Well, there's a third one showing up down here. This was actually not a server, but I think that was one of the machines on our network that someone connected to, and that could have been that one of our team members connected to someone else's machine. And then the services that we offered were these 6, and it was all kinds of weird things. I don't even remember anymore what it was last year, port 9999 or something, and there was some mud running there. But this gives you a very quick way of looking at what is happening in this network. Well, I took it a little further, and I had an idea, or a few people had an idea. I said, well, maybe it's a TTL of the traffic coming in. Maybe you can distinguish the good traffic from the bad traffic by looking at the TTL. So, well, what I did is I said, okay, show me the source IPs to destination IPs, and then the TTLs of that traffic. So you see here, I have 8 TTLs showing up, 8 distinct TTLs, everything from 35, 50, 52, 62, 63, 64, 128, and 126. Some of them are showing up if my teammates would connect out, so I could filter them out. I was not interested in those. I'm just interested in the ones that happen of the traffic coming in from this one evil IP. Let's go back quickly again. And then I figured out, well, I still can't quite tell what is okay and what not. So I had to reconfigure my graph and look at some other properties. So what I did is, I said, well, I'm not really interested in the IPs. I know everything is coming from this one IP that I'm interested in, so only show me the traffic from that guy. But I'm interested in the destination ports, the TCP flags, and the TTLs. So I wanted to see like the SYNs, the SYNACs, the pushes and whatever, and their TTLs, and what port they went to. So this yields this graph here. And in addition to that, that was not quite enough to figure out what's really going on. I need to have the counts. I'm going to lose everyone here. I need the counts on all these nodes. So how many times did certain flags show up? So let's take one example here. I have port 80 here. It showed up 2,600 and something times. And these are all the flags that showed up with the different TTLs. So there were 4 TTLs, 1, 2, 3, 4, that were used when someone connected these ports here. And here are the TCP flags that were being used for this traffic. So I had a theory. I said, well, I'm looking at all the connection establishments, all the SYNs, and I want to see how many times they happen. The scoreboard traffic is probably going to all the services like in sequence, or probably the same amount of time. So I will see the same amount of SYNs going to each of the destination ports, and if the theory about the TTL is right, they all use the same TTL. And it turned out that we were actually able to figure out the TTL for the game last year that way, and we filtered all the other traffic. But it was a little late in the game, so we still didn't win. All right, so I have some other logs here. At some point I was interested in email logs, and I wrote a little sendmail parser, and that's actually part of the Afterglow scripts that you can have on the CD or you can get from SourceForge. The problem in sendmail, I will mention that in the end, I guess. There are always two entries. It says from so-and-so, and then there's a message ID, and then the next log entry says to so-and-so, and there's a message ID to link those two events together, or those two log files, log entries. So I had to write a tool to actually put them together, and then output a CSV file and all that stuff. And the result is this one here. So I'm just showing who is talking to whom via email. And then I said, well, what's probably interesting is to see everything that's coming from my domain, the one that I'm really hosting on that server, going to people outside, and what is coming into my domain. So I colored the whole graph that way. And if we look at the zoom up here, you see that these people here are quite popular. A lot of people from outside, these red nodes, are sending emails to this guy that was hosted on this server. Here you just see the popular people. You might be interested, I don't know, maybe you want to get to know them. But I was really interested in whether I'm running an open relay. I'm not, but I'm pretending I will. So what I did is I said, well, here we go. Just show me everything on the outside, all my domains, or all the, like, rafi.ch or whatever my domain is, don't grade them out, and just show me the rest. So you see, there's still some others showing up here. So what I did then was I used Afterglow to just eliminate all those. I'll show you how to do that. You can set nodes on invisible. And here, I realized, oh my God, there are actually people using my server, like this guy here, to send emails to people that are not hosted on my server. So I'm probably running an open relay. Well, some other things I was interested in, well, am I running, or is anyone spamming? And, well, probably, hopefully, I see something in here. Otherwise, my graph would probably not be very, my configuration would not be very good, because probably on every mail server you'll find spam. So what I did is, in the email log, you see the size of the messages. So I just visualized who is getting what sizes of messages. And I was interested in just the ones that are above 10,000. All the others I'm not interested in. So you still see that, for example, down here, there are multiple recipients that get the same size messages. So that means that someone probably is sending emails to a few people, and this email is pretty big, and it's probably the same one because they have quite a high size, or the same size. So that would be one indication of maybe there is something spam going on. Probably not. Well, another way of looking at whether you have spam is look at the number of recipients. In an email, you can send emails to multiple people, right? So the number of recipients in the log file would indicate how many people got this email. And what I said, well, I want to see everything that's bigger than 2, and all the things where someone is just sending to 2 other people, I don't want to see. So I have this omit threshold thing in Afterglow. I will explain it in a second, where I can drop out nodes that only connect to 1 other or 2 others, so I can filter out the things they are not very interested in. I'm interested in the bigger, the fans or the circles showing up. So when I did that, I realized, well, only this one comes back here. There are like 10 recipients and 7 and 11, and it's always from this free club report at news.ch. So it was probably a newsletter, and maybe it was spam. You can take this further and further. You can have you look at very big emails, maybe someone is sending out documents from the internal network to someone outside. I'm going to skip over these a little quicker to show you Afterglow. Another one is there's a field called delay on the email server log, and that shows you how long was the email queued on the mail gateway. And what you see here is that there was apparently some problem here with these big two clouds, this one here and this one down here. These emails stayed on the server for more than 10 minutes. And it happened a lot of times, as you can see, to these two email addresses, this one here and this one down here. So there's some problem with those addresses. Maybe they're wrong, and you can go in and either block them or do something about them or figure out who was sending the emails out to these guys. And this might actually be also a way to detect spammers because they send these huge lists of emails, and probably a lot of them don't exist, and they will be queued in the system. They might retry all the time, so getting a lot of delay. So maybe you can figure out who your spammers are. Okay, let's get to the gist here, to Afterglow. You find it on SourceForge. As I mentioned earlier already, we support two output formats. The GraphViz library from AT&T, or also known as .NETO, and the LGL, the large graph layout by Alex Adai. So Afterglow is just a Perl script. You can pass it the input, it reads some standard in. You can pass it a few parameters to configure it. One of them is, if you do a -t on it, it expects a 2-column input. So just from to, or size and recipient or something like that. So -t reads 2 columns. If you don't do the -t, it expects 3 columns. So you can do all these like source IP destination port things. If you do a -d, it will print the count on the nodes. That was that weird example from Capture the Flag I showed you, that you actually see how many times did that node show up in the log file. Then you can pass it an edge length to kind of optimize how your graph is going to look. If you have a length of 5, then things will be really distant from each other. But if you have big clouds around one of the nodes, that might be helpful. With -n, you can disable the node labels. So sometimes you have logs, if you can't parse them really well, you have really long tokens, so they will really clutter your graph. So just turn them off, and you get a kind of a feeling that there are certain things going on, and then you have to go back to the log file and figure out what those nodes were. This -o thing, this threshold that you can set, if you have a log file of communications, like someone is talking to someone else, and you see a lot of people that just connect to one other machine and nothing else, and then another machine to something totally different. But then you have these big clouds. A lot of times, I'm not interested in these like one-to-one connections. I really don't want to know about those, but I'm interested in the big clouds. So if you do a -01, it would kill everything that has a fan out of 1. And this feature is not quite complete. It doesn't do the whole traversing of the clusters and figure out whether it's connected to other clusters. Play with it, it's kind of cool. There might be like one-off cases that look kind of weird. And then the most important thing is the -c. You can pass it a color property file. I'm going to show this in a second how this works. So the property file just has color dot, for example, source equals, and then you can pass it a Perl expression, and the expression just has to return a color, like red, this string. Then there is an array called fields that contains the columns that you passed it in. So for every line, it will evaluate this array. So you can say, like the event node is red if the first column, so that's really the second column, if fields 1 matches this regular expression. So if it's in 192, then make it red. Then I have the special color called invisible. If you say that the target is invisible if this expression here matches, then it won't draw that node. So you can kick out certain things by certain expressions. Or you just have a simple color. You just say color.edge equals blue. So here is the fancy example with the firewall graph. I'm just very quick. So this is the property file. You say the source is olive drab if the field 0, so if the first entry that you get is 191, 141, 69.4. That's one of my IP addresses. It's not really, so go and play with it. So they show up green, and then everything else, so like first match wins. So if it falls through, it will just be orange-red. So everything outside is going to be red. Then you configure the nodes, they'll be blue, the targets. Like, I think you get the idea here. You can have really complicated things on the edges, for example. For ingoing and outgoing traffic, I had to say if the first column is inside my network, or the third column, which is the destination IP, is inside my network, then give it a firebreak color. And otherwise, just use the other color. Afterglow also has 2 parsers I give you. And I just realized, I just put this slide in last night at like 2:30. I hope there are no typos. I realized that these 2 parsers are actually quite useful. I used them at Capture the Flag yesterday. If you have a TCP dump log file and you want to visualize that, you have one problem. You see requests from a high port to port 80. Then you see the response going from port 80 to a high port. If you visualize that, you will see the high port and port 80 as source ports. And that was what I was showing in the other graph, basically. And then the destination port, again, same port numbers. So you need to, for the request, you need to flip the ports so that you have the connections again. And the TCP dump to CSV takes care of that. It remembers what direction the connections are going and automatically flips them, so you get nice output. And then the sendmail parser combines the sendmail log entries into one again that you need. That's really it. Any questions? Wow, everyone is tired, yeah? So the question is whether I'm thinking about using like a database to drive or to read from or something. Well, Afterglow is really just like a Unix script, right? You use pipes and you pipe in data and you get data out. So it's pretty easy to use a SQL database. For example, you use the TCP dump to CSV. You pipe that into MySQL -e, insert into blah blah, and you get it into the database, and then you can have it pipe it into something else, and you read out the stuff from the database. So you plug it basically into whatever you want it. We basically just provided this Afterglow to take the CSV, to add the color and then everything to that graph file and generate the graph file, and then you use the grapher to generate the graph. But please feel free to contribute anything to the SourceForge project. And also, if you're going ahead, go home and visualize and get some cool graphs. I'm always interested in getting graphs, so spam me with cool pictures. How fast is it? Well, most of the time is actually consumed by Nido. That's what I use to generate all these graphs here, because it has to generate the layout. And it really depends on how many nodes or how many log entries you're passing in. If you have probably about, let's say we want to have a refresh rate of like 30 seconds. I think that's good because you need time to look at it, and then it's going to change completely again. That's going to be one of the problems. You don't see nice delta updates. You would have to handle that somehow. Might be something that maybe Greg and I could work on. So if you're 30 seconds, it's probably safe to use up to probably 5,000 events in 30 seconds. That should probably work. I think I did something like that yesterday with the Capture the Flag data. I have 2 more books. So I guess I give them to the 2 gentlemen that asked the questions here. Anyone else? All right, thank you very much.